Okay. So the difference in these different variants is the number of uh, RTTs required to establish a key, okay, or encryption, and the type of encryption algorithms used. We'll see, okay. And the second option is transport layer security, transport layer security, TLS, and TLS is based on SSL, obviously, but it's more modern and is more secure, right? It uses modern encryption algorithm. It takes less amount of RTTs required to establish a key. Okay, so it's based on obviously based on SSL. Okay, and it has different versions such as TLS 1.0, 1.1, 1.2, and 1.3, right? So I'll be talking about all. Okay, first, it is important for us to establish the understanding that how, when we communicate, when we communicate with a server, a web server, how we can ensure that we are securely sending requests and receiving responses. Okay, so for that, let me use this scenario. For example, I have a client. Okay, and then I want to interact to a server, and this is my web server. And then I also need a third party here, known as CA. CA stands for you know certificate authority. Okay, certificate authority, CA. Okay, so there are many private certificate authorities available. For example, we have GoDaddy, uh, we have GeoTrust, right? DigiCert, uh, Cloudflare, right? So these are the examples of. Let me write here. These are the examples of certificate authorities. For example, GeoTrust. Okay. Then we have DigiCert, right? Then we have GoDaddy, right? And there are many, right? So what's the role of a certificate authority? We'll see in a minute. Okay. So before a client needs to access a web server, whenever we establish a web server, the web server needs to get a certificate, right? And for that, the web server will send its public key to the certificate authority, right? Before this all starts, and for example, I have deployed a web server, so my web server needs to send its public key, send public key. So public key can be think of a key which is known to public, right? For example, I just giving an analogy here, not an example, by the way, that your email is can be think of your public key and your password is your private key. So the email is known can be known to anyone, right? But your password cannot be. Okay. So uh, upon receiving this public key, what the server, the certificate authority does is it signs the public key from the sender or the server using CA's private key, right? So what it does is CA sign the public key from server, and it will sign it with its private key using CA's private key. Okay, private key, and it is called digital certificate, right? Right. So whenever we have to establish a new, uh, you know, uh, server, the server will send its public key, right? The public key of the server, web server, will be signed by the private key of the certificate authority, and this will result into something which is known as digital certificate. Am I clear? Right? After generating this digital certificate is shared with the web server. Okay. So the certificate authority return signed public key. Okay, signed public key. Okay, or you can say will return the digital certificate. So this is a prerequisite step. Before any client can interact with the server, this web server needs to talk to the certificate authority by sharing its public key, and the public key of the server will be signed by the CA's private key to make a digital certificate, and it will be returned to um the server. Now, client comes in, and there's a client who wants to interact with the server. The client will send a TLS hello, right? So the client is sending, uh, or you can call it client hello, right? So client TLS hello, client TLS. TLS is transport layer security. Okay, hello. At the moment, I'm not talking about that it's 1.1 or 1.2 or 1.3. Let's forget it, right? So we'll talk about it later. Okay. So when a server receives, you know, client TLS hello, the servers, needs to generate a response, right? So server sends a response, and the response is known as um server TLS hello, right? So, so it sends a uh, server TLS hello or servers hello. Okay, but most importantly, we need to have a look at what this server TLS includes, right? So this server TLS includes encryption protocol, a random number, and server's digital certificate. Okay, so most importantly, um, this includes this is important for us to understand that this includes what encrypted selected encryption protocol or cipher, selected uh, encrypted cipher suite, encrypted cipher suite. I mean the list of encryption algorithms that are supported by the server, and a random number generated by the server, right? So I can call it server random. Here, server random represents a random number generated by the server, and and what most importantly, a digital certificate and sign the public key of the web server with its private key, and this is known as digital certificate, right? So server has web server has got it from the CA. Okay, right? So whenever we send a request, I mean before we send, our request is entertained, there is a client TLS hello. Okay, whenever we type google.com, for example, the prerequisite is that first of all we need to send what? A client TLS hello. Okay, in response to client TLS hello, server sends server TLS hello, which includes what? Which includes a list of the encrypted encryption algorithms or encrypted cipher suite that is quoted by the server, and a random number generated by the server, and the digital certificate. Okay, this is very important that client verifies that this server is a legitimate server. Okay, for that, when a client receives server TLS hello, client does following, right? So what this client does is it uses CA's public key. So first of all, the client needs to verify the digital certificate of the server, web server. For that, the client will use certificate authority's public key to verify the server. Okay, so use client uses certificate uh, authority's public key. This public key is available in our browser, right? So our browser has the updated record of the public keys of all the you know of all the certificate authorities. Okay, right? So user client uses what? C is public key to verify the server, right? So the first thing is to verify the server. Is it a legitimate server or not? Have you ever crossed a message where it says that digital certificate has expired? So this is because that the web server's certificate cannot be verified, right? Your browser is unable to verify the web server's digital certificate. Okay. So the first thing is to verify, and for that, see what we are using is what we are doing is we are using this public-private key pair, right? We are using this public and private key pair. Okay. if we are if we are encrypting something with public key, it can be decrypted using private key. If we are encrypting something with private key, it can be decrypted using the public key. Yeah, in encryption, public key and private key pair means that if anything is encrypted with the public key, it can be decrypted using its private key. Okay, am I clear? And if it is encrypted using private key, it can be decrypted using the public key. This is the the purpose of this public and private key pair. What is this digital certificate? It is web servers public key. Yes, no? Encrypted by CA. How? Using its private key. Encrypted. This is something which is encrypted using CA's private key. So I can only decrypt it using its public key. And
Private key.
uh,
Okay, so public.
public key, and all the public keys of all the certificate authorities are part of our browsers. Right? So when we update our browsers, our browser has this updated public keys of all the right. So Mike, off करना Salman, Salman, thank you. So if I decrypt it, what I will get, the public key of बोलिए शाबाश
Web server.
web server, right? And this will be very helpful to us, right? आपने इस पे नजर रखनी है. When I verify the public key, verify the digital certificate of the server using public key, when I decrypt it using public key of the CA, I will get the public key of the web server, number one, upon receiving server TLS hello. Then it creates it creates a pre-master. It creates a pre-master secret. Okay, so a pre-master secret is created. A key is created, right, using the random number provided by the web server. The client using uh, an encryption algorithm from the encrypted cipher suite generates a key, which is known as pre-master secret, right? And what it does is, and it's signed and signed it with the public key of the server, of the web server. Right. So this is step number one. This is step number the second thing the client has to do. Right. First is to verify the web server's certificate, digital certificate, and the second is to create a key using the random number provided by the server, and this key is encrypted by the public key of the web server. Second, we have to send this information again over the internet. Anyone can listen it, right? Using Wireshark or any other tool, anybody can listen it, right? So only the server will be able to decrypt it. Why? Because it can be decrypted using the server's private key. Okay. So now, whatever we have done this, I mean, which is basically the we have generated pre-master secret will be sent to the web server, right? So now, after performing all these steps, it will send pre-master pre-master secret to the server, right? Now, what the server has to do? What will server do? The server will first of all need to decrypt it, right? The server um, uses its private key private key to do what? To decrypt the message. And what is inside the message? And get what? The key. Pre-master, pre-master secret. Okay. Okay. So up to this step, what they have done is they have shared a key for the rest of the communication between the server and client for all the requests and the responses, everything. So we'll send HTTP request, right? Uh, and we'll receive HTTP. So this is HTTP request. Okay. We'll receive HTTP response. Okay. No matter how many of these are. Okay. These HTTP requests and responses will be encrypted using this pre-master secret, right? Only one key, right? Because we are using only one key, we call it a symmetric encryption. We call it what? Symmetric. We call it a symmetric encryption, or we also call it session key. Okay. So before we send a request and receive a response, we in HTTPS we have to establish a key securely, right? So now we are not using this public private from now onwards. We are not using this public private key pair, right? No, we are not using this. We are using one key. That's why we call it what? Symmetric encryption. And this one key is known as secret. And all these, interestingly speaking, all these variants that we have listed, about 1.0, 1.1, 1.2, it all, is based on how many number of RTTs are required establish this shared secret, or this, symmetric key or session key. If I look at this example, so first of all, I have to send, request, then I have to, this is 1 RTT. Yes, no? right? And then again, the key is sent, and then so it takes two RTTs, okay, to establish what? To establish a shared secret, right? So we want to reduce this. We want to reduce it to one RTT in TLS 1.3, right? So, for example, I will give you the example of TLS 1.3, which is the latest transport security standard. It uses one RTT only, right? One RTT to do what? Here, or to establish a shared secret. Okay, okay. One RTT, and in some cases, we it takes zero RTT. Interestingly speaking, we'll see how. Okay, so I mean the fundamental difference here is the standards that we are using, right? For example, in TLS we use AES, GCM, for example, advanced encryption standards, and most importantly, to achieve this, right, we use Diffie-Hellman. Okay, so in order to achieve what? In order to establish a shared secret in one RTT, it makes use of uh, uh, elliptic curve Diffie-Hellman, right? Ephemeral key. So what it uses is elliptic curve Diffie-Hellman, right? This is elliptic curve Diffie-Hellman ECDH ephemeral key. Ephemeral means temporary key. Okay, so it uses Diffie-Hellman to establish a key in single RTT. Means what? So this means between a client and a server, it will take only one RTT, okay, to establish a shared secret. Okay, how we can do this, right? So server will send information, and the client will use it, and the both will create the same key in one RTT. Okay, the difference in all these variants is number one, the encryption algorithms, right? In TLS we have advanced encryption algorithm. Obviously, these are the recent standards. Okay, whereas in SSL we have older, for example, encryption standards. Okay, but the most important challenge is how you can establish a shared secret in one RTT. For example, so just for your information, if I talk about SSL, so SSL uses algorithms such as RCH, MD5, okay, message digest 5. These are old, standards. And if I talk about TLS, it uses SHA 256, AES. AES is Advanced Encryption Standard, right? CHA 20 is very common. CHA 2.2, right? And there are many others, right? So the number one difference in these is the you know the encryption algorithm, and the other difference is that both sides generate temporary keys to create a shared key, right? So, for example, TLS uses elliptic curve Diffie-Hellman ephemeral key. I mean, the temporary key to create a shared secret, right? So for that they need to create a shared secret in one RTT, let's see how we can do it using Diffie-Hellman. Let me give you an example first. Let's assume that the client generates a key using this method. Client's key is equal to the the key that the client will use to compute the shared secret, right? Okay. So let's say on the client we have to calculate this key. Client has these values. Okay. So client has their you know a, which is the which represents the private key of the client is 6. I'm taking some numbers so that you can understand this, right? Then on the client we have G, which is uh, you know uh, some base value. On the elliptic curve, say 5. P is a large prime number, say 23 as well. Okay. So how we can calculate this A, this ephemeral temporary key हमने पढ़ा ऊपर देखा है, which is G raised to power A mod P. Yes, no? Yes. Let me put the values. G is 5. 5 power to the power is 6 mod 23. And uh, this comes out to be 15625 mod 23, which is equal to 8. But this 8 is what? This is the ephemeral or the temporary key. Okay, and the client will send this temporary key A to server. Okay, so client will send this to server. Done. Similarly, server will create its own temporary key, and let's say B is 15. Okay, and G is the same, right? So G is, for example, 5 mod, sorry, P is large prime number is 23. And how we can calculate a temporary key at the server? Again, we know that B is, which is the temporary key of the server, is G to the power B mod P. Okay, so which is what? 5 to the power 15 mod 23. And if you solve it, we get 19. And server will send this to client, right? So server will send 19 to client, and now the both will calculate the shared secret, right? Let's see how using this temporary keys they can calculate what they can calculate a shared secret. Shared secret S. So client will calculate a shared secret S, um, which is equal to B raised to power P to the power A mod P to the power the private key of the A B mod 23. This comes out to be 2. Okay. Similarly, server will calculate what this shared secret, how A, which is sent by the client, which is 8, power its private key, say B mod P to the power 15. Yes, no? Yes. Mod 23. And if you do it, it again comes out to be 2. So do they have the same key or not?